So very good morning to one and all. Myself, Dr. Kamsha Dubey, Assistant Professor of History of the Gods. So today we'll be talking of organometallic compounds. So organometallic compounds are chemical compounds which contains at least one bond between a metallic element and a carbon element belonging to any organic molecule. So every metalloid elements such as silicon, tin or boron are known to form organometallic compound having a bond between a metal atom and a carbon atom, which is used in industrial chemical reactions. Now the catalysis of these reactions wherein target molecules are polymers or pharmaceuticals also, which can be done with the help of organometallic compound, resulting in increased rate of reaction. Now generally the bond between the metal and the carbon belonging to organic molecule is a covalent bond in nature. Now, when metals with relatively high electropositivity such as sodium or lithium form these compounds, a carbanionic nature is exhibited by the carbon which is bound to the central metal atom. Now here is a diagrammatic representation which is example for organometallic compound where carbons belonging to the benzene molecule bond with chromium as it is seen in the example. Now a few more examples of these compounds are Grignard reagents or tetracarbonyl nickel or dimethyl magnesium. So basically these organometallic compounds are of great importance in synthetic chemistry as they involve the formation of carbon-carbon bonds along the metal. So organometallic chemistry is a study of these organometallic compounds or chemical compounds containing at least one bond between carbon atom of organic molecule and a metal, including alkali or alkaline earth metal, also transition metals. Now, since many of these compounds without such bonds are chemically similar, so alternative may be compounds containing metal element bonds of largely covalent character. So organometallic chemistry combines the aspects of inorganic chemistry along with the organic chemistry. So organometallic compounds are also termed as organometallics and can be defined as a material which possesses direct more or less polar bonds between metal and carbon atoms. In addition to traditional metals, lanthanides, actinides and semi-metal elements such as boron, silicon, arsenic, selenium are also considered to form organometallic compounds. Example, organoborane compound which is triethyl borane. You can see the image. Now here carbons are always more electronegative compared to the metal atom. Now types of organometallic compound, if we talk of, there are two types of organometallic compound. One is simple organometallic compound, the other is complex or mixed organometallic compound. Now simple, when we say in this, metal is linked to only R groups or alkyl groups. These are covalent in nature, say for example dimethyl zinc, where you can see methyl groups are connected on either side with the zinc. Now, if you talk of complex or mixed organometallic compounds, so in this type of organic metallic compound, metals can be attached to alkyl groups along with the halide also. Now, these are having carbon metal bond with ionic character, where you can see Grignard reagent is best example for it, where metal is in between, one side halide is connected, the other side alkyl group is connected. Now here the ionic character of carbon metal bond depends on the nature of the metal and decreases in the order. For example, potassium will have the highest ionic character compared to mercury, and it decreases from potassium, sodium, lithium, magnesium, aluminum, zinc, cadmium to mercury. Next, if you talk of classification of these organometallic compounds based on the nature of carbon-carbon bond, so it could be ionic, covalent, electron deficient or transition metal organometallic compound. By the name as it suggests, ionic usually is with group 1 elements, covalent with group 2 which forms a covalent bond, electron deficient metal atoms like lithium, beryllium, magnesium might also form this, and transition metal organometallic compounds are also formed. Now ionic, as I told, are generally formed from the elements such as sodium, potassium, where the metals are considered as electropositive and ionic bond is formed. So if the organic groups are able to delocalize the negative charge over several carbon atoms, then less electropositive elements like magnesium can also form this ionic compounds or a organometallic compound. Now if you talk of covalent, the simplest model of this is metal carbon bond, where it consists of essentially single covalent 2 electron bonds, whereas one electron from one, the other from the other. Now these compounds are often volatile and comparable to typical organic compounds, being soluble in organic solvents. Next, electron deficient organometallic compounds are generally associated with elements that have less half-filled valences and are designated because of insufficient number of electrons. But then it allows all the atoms to be linked by traditional two-electron two-center system or two-center bonds. Now, compounds here might be bridged or polymeric structures. The methyl derivatives of lithium, beryllium, and ammonium can be found here. So talking of another major example of organometallic compound, which is Grignard reagent, which can also be termed as organomagnesium halide or Grignard reagent because it was discovered by Victor Grignard, hence it is named as Grignard reagent, for which he was awarded a Nobel Prize in 1912. So here representation, if you see, it is RMGX, where R can be alkyl, alkenyl, or aryl group also, and halides can be chlorine, bromine, and iodine. Now preparation, if you talk of, so Grignard reagent can be prepared by action of magnesium on alkyl halide and anhydrous ether or in presence of anhydrous ether. So here if you see, you take Rx, you react with MgX, you reflux in presence of anhydrous ether and you form a RMgX, where R can be any methyl group or any alkyl group. Now reactivity order of this alkyl group decreases from methyl to CH3H7, that is bromide. Now, in other words, increase in carbon atom leads to difficulty in formation of Grignard reagent, whereas if you talk of reactivity of halides, so again it decreases from iodine to fluorine. So procedure of preparation of Grignard reagent includes that small pieces of magnesium metal is suspended in dry ether in 3 ground bottom class, as you can see in the diagram. So mixture of methyl iodide and anhydrous ether is placed from dropping funnel and 2 to 3 ml of this is added into reaction flask. Then you add ether. When the reaction starts, ether becomes cloudy and begins to boil with visible signs of magnesium reacting. If it is reaction is not initiated, you again add crystals of iodine for it to start the reaction. And once it is started, you maintain addition of methyl iodide and ether solution from the dropping funnel. So when the reaction is complete, a clear solution of Grignard reagent is obtained. Now this reagent can then be treated with different other chemicals to obtain a desired amount of product. Now, structure-wise, as I told, it can be written as RMGX, where R can be any alkyl or aryl group. Here, clear examples are also given. Now, talking of reactions which Grignard reagent can have, so it can have reactions with compound containing active hydrogen. So here, if Grignard reagent is reactive with compounds containing active hydrogen, it forms hydrocarbon. So here, if you see, methyl magnesium iodide, when treated with water, has formed methane, and again MgOHI comes out as a side product. So next reaction is again with carbonyl compounds. So here carbon magnesium bond is polar and generates nucleophilic reaction. So here nucleophilic carbon of Grignard reagent attacks the carbonyl carbon and again attached to the oxygen of carbonyl group of aldehyde and ketone, and an adduct is formed. Later, if you talk of reactions with aldehydes, so the last product would be your ethyl alcohol or formaldehyde when reacts. As here clear example, if you see, you can say that Grignard reagent when reacted with aldehydes may form alcohol or primary alcohol at the end. So here example is for formaldehyde, which when reacted with methyl magnesium iodide formed ethyl alcohol and Mg salt side product. Talking of ketones, ketones when react with Grignard reagent, it forms tertiary alcohol. So here also ketone, if you see, is reactive with methyl magnesium iodide, forms a tertiary butyl alcohol, and an intermediate or a side product is formed. Now talking of reaction with esters, esters also leads to formation of tertiary alcohol. So it first reacts with Grignard reagent to form a ketone, and again ketone will undergo hydrolysis to form a tertiary alcohol. Talking of acid halides, so acid halides reacts with the Grignard reagent to again yield a tertiary alcohol. But it occurs in few steps where it gets converted to acetone and ketone, or you can say ketone will get converted into tertiary alcohol. Epoxide again will lead to your primary alcohol, not the tertiary alcohol. So epoxide reacts with the Grignard reagent to form alkoxide, again followed by hydrolysis, which will lead to formation of propyl alcohol. Carbon dioxide will form again carboxylic acids. So here if carbon dioxide is reacting with methyl magnesium iodide, forms acetic acid and MgICl as a side product. So protonolysis is again one major phenomena occurred by Grignard reagent. So here it actually refers to cleavage of chemical bond by the presence of proton donor. So when carbanion in Grignard reagent comes in contact with water, acid or any proton donor, it undergoes protonation, leading to the breakdown of the carbon metal bond and resulting formation of hydrocarbon. So this process in which carbon metal bond of Grignard reagent is broken by the addition of proton donor is known as protonolysis. So today we'll be studying again limitations of Grignard reagent, and we'll stop by this. So limitations, if you talk of Grignard reagent, is strong base and it cannot react with compounds containing acidic hydrogen. Reaction also tends to be very slow. Significant of magnesium is consumed by activating the agent during reaction, so it cannot be used as a limiting reagent. And atmospheric humidity can interfere with the reactions affecting the yield and preparation of Grignard reagent from magnesium turnings and alkyl halides. So it does not react with any of the functional groups such as alcohol, carboxylic acids, amines, alkynes or amines. Thank you.